Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, in this problem, I have two arrows, arrow 1 and arrow 2. Um, now, we know that arrow 1 is initially shot with a velocity of 25 meters per second. And we also know that we're on the planet Earth, so the acceleration due to gravity of arrow 1 is negative 9.8 meters per second squared. Now, this problem talks about the fact that these two arrows reach their maximum height at the same time. And what that means for both our arrows is their final velocity is 0 meters per second at that maximum height value. Okay, so at some time after being launched, this arrow reaches 0 meters per second. Now, the second arrow was not launched at the same time. It was launched 1.2 seconds after. And what that means is the time the second arrow is in the air is not t, rather it is t minus 1.2 seconds. So we don't know exactly what it is, but we do know how it's related to the time in part 1. So we can define both of those variables using only one letter, t. And arrow 2 is also on the planet Earth, so we have an acceleration of negative 9.8 meters per second squared. Okay, so our end goal here is to be able to figure out what that initial velocity of arrow 2 was. And looking at this for kinematics, remember that anytime you have three numbers you know, you can solve for the other two. So right now I have three numbers that I know about arrow 1, but not three numbers that I know about arrow 2. So I'm going to use the variables I know for arrow 1 to find the time that arrow 1 is in the air, plug that into equation 2, and use that to find the initial velocity of that arrow. So with that, let's look at what we have. For the first part, we don't know the distance, and we also don't care about it. So when I'm looking at my equations, I'm going to use the first one because it doesn't have an x in it. It is just v equals v naught plus at. So when I plug in my numbers here for part 1, we have 0 equals 25 minus 9.8t. So 9.8t equals 25, and the time that arrow is in the sky is 2.55 seconds. Okay, now I'm going to move this work out of the way a little bit because that gives us our third piece of information that we need to determine what the initial speed of arrow 2 was. Because since our total time is 2.55 and we know the time for arrow 2 is 1.2 less than that, our time for arrow 2 is 1.35 seconds. And now we just need to find this initial velocity. So using the same equation, we have final equals initial plus acceleration multiplied by time. Then if we rearrange it, our initial is going to be equal to our final minus acceleration times time. And we get our initial velocity once we plug these things in of 13.23 meters per second. That's how fast that second arrow was shot.